Hello everyone, in this video let's discuss about 2:1 mux. It is also called as 2:1 multiplexers. If you are new to our channel, please subscribe for more engineering related topics. So what is multiplexer or mux? What is multiplexers or mux? Multiplexers. So these multiplexers or mux are used for data communication. So they are used for data communication in single channel or single line, in single or common line. So multiple datas, that is multiple datas travel through the single line. That is like multiple cars, there are 3 to 4 cars traveling in a single lane of road, like that. So what this 2:1 represent is 2 will represent the number of inputs, 1 will represent the number of outputs. So therefore we used to know in 2:1 mux there will be 2 inputs and 1 output. So to design the 2:1 mux and get full marks, so we should follow the 4 steps. First step is block diagram. Block diagram. Next, second step is truth table. Truth table. Third one will be equation or circuit equation, you can call it as. Fourth will be the circuit diagram. Circuit diagram or logic diagram. Now let's draw the block diagram. So block diagram is the simple representation of inputs and the outputs which we are using in the circuit. So I already said 2 inputs will be there, 1 output will be there. So I will call the output as Y, and 2 inputs. So I will call it as I0, input 0, input 1. So total 2 inputs. So in this multiplexer, we will be using the selective lines. So how many selective lines we must use? How can we get it now? So it is simple. How many number of inputs are there? 2 numbers. So how can we represent using the 2 powers? That is 2 power 1 is equal to 2. So 2 number. If there are 4 inputs, that is 4:1 multiplexer will be having 4 inputs. How can we select the selective lines? How can we represent 4? 4 can be represented using 2 power 2. What is the power? Power is 2. So therefore 2 selective lines will be required in 4:1 mux. Here how many number of selective lines are required? Only 1 number of selective lines are required. So I will call these selective lines as S0. S0 is the one selective line we are using in the 2:1 mux. Now using this block diagram we will be drawing the truth table. So in truth table we will be representing the inputs and outputs. What are my inputs and what are my outputs? In output side I will represent Y, but in input side we cannot represent I0 or I1 because the selective line S0 will select the inputs. Selective line S0 will select the inputs. So I will take input as S0. Since I have only one input, so what will be their combination? 0 and 1. So now let's assume that when S0 value, that is selective line value, is equal to 0, I0 will be the output. When S0 value will be 1, I1 will be the output. So now using this truth table, we will be representing them using the characteristic equation. So we will write the characteristic equation for the output side. So we have output side, we are having at output side we are having only one output. So output Y is equal to, what will be their combination? When S0 is equal to 0, output will be I0. So I must represent both. S0 is 0. 0 means I will use bar. So S0 value is 0 and I0 plus S0 value is 1. So I will write S0 itself and I1. So I1. So this will be the characteristic equation of the 2:1 mux. Now using this characteristic equation, let's design the circuit diagram. So to design the circuit diagram, we will see what are my inputs. So see, S0, I0 and I1 are required. So S0 and I1 for this one, and S0 and I0 for to represent this one. First let's represent this one, S0 bar. So bar means what? I will add a NOT gate in front of it, and I0. S0 into I0. So I will use AND gate. Next, S0 into I1. S0 into I1. Into means AND gate. Now S0 bar into I1 plus S0 bar, S0 into I1. So plus is there. So what we will use? We will use OR gate. Now this is the value of the output Y. So hope you understood the concept of the 2:1 multiplexer and knew to draw the block diagram, truth table, equation and the circuit diagram. If you have any doubt, please comment below. Please subscribe for more engineering related topics. Thank you.